Okay, so examples of the power rule, people. This is the coefficient, this is x, this is the power. The power rule applies to what type of functions? Polynomials. What type of functions? Polynomials, right? All functions that are not polynomials, but we can write them like polynomials. Okay, so now I'm going to give you your first function and I'm going to ask you to apply the power rule. Okay, so I'm going to give you a function. The function is f of x is equal to 3x to the power of 4 plus 2x to the power of 3 minus 6x to the power of 2 plus x, right? Okay, let's just move my face a little bit out of the way and let's add plus 1. Okay, now remember, when we deal with this 1 here, this here is actually 1 times x to the power of 0. When we have f of x, to denote the derivative, we use f prime of x. And what we do is we simply take the exponent multiplied by the coefficient. What do you get there?
So it's 12.
12, well done. And you take x and you minus 1 from this, which gives you what? 3. Now we do the next one. Mahir? Positive 6. 1 from 3 you get 2. Okay, let's do another one, people. This one here.
12. Negative 12. Negative 12.
Okay, and what's in front of this x?
A 1.
A 1. And what's the power there?
0.
0. So you're going to say it's plus 1, x to the power of 1 minus 1, which is x to the power of 0, so you don't have to put that in. And then this constant term that falls away. So that's your derivative. Difficult? Okay, let's do another one. Let's look at another example now. I'm going to write down this function, y equals 3x squared minus 5x plus 1. Now earlier I gave you notation. I said if you have y, then you must write the derivative as dy dx, right? So in other words, we're differentiating the function y with respect to x because the variable is x. And I left out this part here, which needs to be a 5x, right? Now, Kayla, can you tell me what's the derivative of the first part? 6x to the power of 1. And this is going to just be minus 5. Because that's 1. 1 times 5 is negative 5. And then 1 minus 1 is x to the power of 0, which is obviously 1, so it's just minus 5. Okay. Can I do another example?
Yeah.
So just leave it like that. dy.
Y equals 4x minus 3 all squared. My question to you is this in polynomial form? No, right? So when I times it out, I still leave this as y because I'm not applying the power rule just yet. So this is going to give me 16 what?
16x
Squared. That's going to give me negative 12x. Double that is negative 24x. And this is going to give me positive 9. Now I go and I apply the derivative dy by dx. Can anybody give me this, Mahir? (16 times 2) 32 x to the power of 1 because we're minus 1 from that, and this is just minus 24. Are you guys already seeing a pattern? If there's a linear term, you're only going to take what's in front of it, and if there's a constant term, that falls away in the derivative. Are we good?
Yeah.
Okay, let's go do some more quickly.